Right now, I'm going to show you something that looks like a glitch. Take a look. This is a real-time map of ship traffic worldwide. The North Pacific is packed. Asia, the Americas, Europe, tons of dots. And every one of those dots is a ship carrying something important. But there's something weird. Let's drop a little farther south. Right here. This is the South Pacific, and it's empty. Now look closer. Sure, you can spot a couple of ships. There they are. But we're talking about a huge chunk of the planet. Open ocean, relatively short routes, and almost no ships. That sounds ridiculous. Just look. Here's South America. And we need to ship cargo from here to Australia or New Zealand. How do we do it? Well, just draw a straight line. That's the shortest route. See any straits or bottlenecks along the way? Me neither. It looks like the perfect route, but in real life, you can cross that line out immediately. Why? Sailors call this area a true hellscape of weather. The wind never stops there. And what does wind on the open ocean mean? One thing: waves. Massive Hold on. That raises a question. Modern ships are steel beasts. Huge, stable, loaded with technology. They should be able to handle it. So why does this patch of ocean look like a black hole for shipping? Why do even the toughest crews, the ones used to the harshest seas, avoid it? You're about to find out. The most restless place on Earth. So here's a place where ships don't want to sail. But have people always feared it, or is that a modern superstition? Let's jump back to the 17th and 18th centuries, when explorers wrote reports about their voyages. In those logs, you'll find lines like endless storms, the ocean's constant roar. There are simply no laws here. What were they talking about? Yup, the Southern Pacific. Even back then, sailors knew it's better to steer clear of that region, and only centuries later did it become clear they weren't exaggerating. They just didn't understand the physics behind it, and that's what I'm about to explain. There's a term for it, the Roaring Forties. It's a belt between 40 degrees and 50 degrees south latitude. Calm seas are rare there. Westerly winds circle the entire planet in a continuous loop. And along the way, there's almost no land to slow them down. No mountains, no continental barriers, just open water and acceleration. So what does that lead to? The wind here isn't an event, it's the default setting. Typical speeds sit at around 35 to 56 miles per hour. And gale force blasts can easily push past 67 miles per hour. And the key thing is, this isn't a quick squall that shows up and disappears. It's a mode the sea can live in for weeks. But wind alone still isn't the main problem. The real problem is the waves. The Southern Ocean runs like a giant wave factory with no off switch. Wind drives water for hundreds, sometimes thousands of miles, and each new wave is born on a surface that's already accelerating. In the roughest winter zones, average wave heights climb above 16 feet, and individual crests can top 33 feet. But wait, can't modern ships handle that? They can. The issue is something else. The danger isn't just how tall the waves are, it's their rhythm. The ocean doesn't hit once and let go. A ship gets trapped in non-stop motion with no brakes, rising and then dropping, rolling and then recovering again and again. And now to the most important part. If someone on board suffers a major injury, a heart attack or severe poisoning, you don't just pull into the nearest port. In the Southern Pacific, you can be surrounded by thousands of miles of open water. A helicopter may have nowhere to reach from. Rescue vessels are simply too far away, and the weather often makes evacuation impossible. At that point, the ocean stops being a difficult route. It becomes isolation, pure and simple. And that's still not the whole list of problems. Spaceship cemetery. Let's step away from the ocean for a moment and look up into space. Every satellite, every orbital station has a limited service life. And when that life ends, the hardware isn't left drifting around forever. It's deliberately deorbited so it re-enters the atmosphere, burns up, and whatever survives falls somewhere it won't hurt anyone. And that's where things get really interesting. The crash site isn't chosen as, somewhere over the ocean. It's calculated so that there's basically nothing nearby. No cities, no ports, no busy shipping lanes. And again, those calculations point to the same spot on the map. This is Point Nemo. It's so far from civilization that the nearest bits of land look more like random specks than real places. See for yourself. Tiny uninhabited islands sit about 1,670 miles away, farther apart than many countries are from each other. And if we talk about actual civilization, the numbers get even wilder. Easter Island, the closest permanently inhabited place, is more than 1,860 miles away. So you get it, right? Even the ISS, orbiting roughly 250 miles above Earth, is closer. And really, a huge stretch of the South Pacific is a world where land is a day away or more. No harbors, no Coast Guard nearby, no dense traffic. It's like a house in a vast open field, totally isolated with no neighbors. And that kind of isolation has consequences. September 2002, a small racing yacht, Excalibur, is heading back toward Australia after a regatta. Just a routine passage, nothing dramatic expected. Then the keel snaps. To put it plainly, the keel is the heaviest part under the water, the thing that keeps a yacht standing up. Without it, the boat loses stability and capsizes almost immediately. The predictable result, the crew is thrown into the ocean. And out there, it's wind, waves, and open sea. The nearest port might be only tens of miles away, but during a storm, that distance might as well be another planet. Their distress signal was received, but then reality set in, the part people rarely think about: weather and distance. Helicopters couldn't take off, conditions wouldn't allow it. There were no ships close enough to reach them quickly. The people drifted while the ocean followed its own rules, not the rescuer's schedule. And there's one more reason ships don't usually travel here. It's simple, and it comes down to money. Sailing these waters just isn't profitable, even if the route looks shorter on the map. Sounds contradictory? Let me explain. Economics of the seas. To understand how all of this works, let's zoom out and look at a world map again. Specifically, a map of major shipping lanes. What do you notice? Ships don't crisscross the oceans evenly. Most traffic funnels into a handful of main corridors around Asia, the Americas, and Europe. And that's despite the fact that, in terms of time, some alternative routes could be shorter. So why do ships keep sticking to the familiar paths? Modern ocean shipping has almost abandoned the idea of a simple port-to-port route. It sounds crazy, but it's true. Today, cargo is typically gathered in major hub ports, sorted and transshipped there, and only then sent onward around the world on different vessels. Smaller ports don't survive on direct lines. They connect to the global network through these nodal hubs. But what's the advantage? For one thing, simpler schedules, lower fuel consumption, and more predictable logistics. And that leads to the big question: why hasn't the South Pacific ever really become part of this system? Because there's nothing there to build a hub around. There isn't a single hub port capable of consolidating cargo from the entire region, no intermediate transshipment points at all. And without those, maritime trade can't function the way it does everywhere else. The point isn't just cutting travel time, it's plugging into a stable, reliable network. And that's exactly what the South Pacific is missing. So what about that pair of ships we spotted out there? Well, some people sail even into harsh conditions, and they're after one thing only: the ocean's bounty, fish and seafood. Yes, I'm talking about fishing vessels. You'd think you could fish as much as you want with no one to stop you, but no, it's not that simple. The biggest desert in the world. Before we figure out what's going on there, let's do a quick sweep of the entire Pacific. The North Pacific is where massive fishing fleets and industrial powerhouses have operated for decades, basically a seafood factory on open water. The Central Pacific isn't sitting this out either. Historically, tuna and other fisheries have thrived there. But the Southern Pacific is the place fishermen usually don't bother with, because there's simply nothing for them to do there. Why? Here's the simple version of how the ocean works. Where there are lots of fish, the water is being fed from below. Cold currents rise from the deep, bringing nutrients with them. For the ocean, it's like fertilizer for soil. Plankton eats the nutrients, fish eat the plankton, and the whole food chain follows. So what, does the South Pacific work differently? Exactly. It's as if the ocean decided to put a padlock on the supply room. Deep water barely rises to the surface, a warm top layer sits above, cold water stays below, and the two hardly mix. As a result, the surface is warm, crystal clear, and almost empty. In short, it's a vast desert, useful mainly as a dumping ground for burned-out spacecraft. For everyone else, there's nothing to do there, and if there is, it's too dangerous. But what if I told you there's a place that's even more dangerous, and ships still sail through it all the time? You'll see what I mean in a moment. Not the best place for sailing. Take a look at the map. This is the Drake Passage. It looks like an ordinary gap between two continents, but by some estimates, around 800 ships have been lost here over the past few centuries. And that's only a rough figure. Those are just the wrecks that we recorded. How many actually went down is anyone's guess. Verifying it today would be difficult, and here's why. Remember the roaring 40s I mentioned? This is where that phenomenon hits peak intensity. Average wind speeds in this area often sit at 34 to 45 miles per hour. not during a storm, but as the baseline. In major gales, gusts can easily climb past 56 to 67 miles per hour. And that's not even the worst part. The waves are even more brutal. In fairly normal conditions, wave heights run 10 to 16 feet, and that's considered manageable. During storms, seas build to 26 to 33 feet and sometimes 39 to 49 feet. To put that in perspective, you're looking at the height of a 3 to 5 story building, except that building is moving, constantly slamming into the ship. And there's one more interesting twist. It's not just the wave height that matters, it's their shape. Here, the waves are short, steep, and stacked on top of each other. The ship simply can't sync up with the sea's rhythm. It gets slammed upward, twisted sideways, and washed over all at once. Sounds like a perfect recipe for shipwrecks, but that's only the beginning. Antarctica is close by, and it has a huge impact on this strait. The water's so icy that a person who goes overboard loses strength within minutes. Even if the vessel survives, rescuing the crew becomes a race against time. And don't forget about icebergs. And not just icebergs. This place has the full sailor's nightmare kit: fog, a lack of reliable charts, and poor communications. So any damage, a snapped mast or loss of steering, can go from problem to death sentence fast. What about modern ships? They're supposed to handle all this. Well, look, about 15,000 vessels pass through here every year, so in theory, things should be working. And technology has come a long way. Ships don't navigate by gut feeling or outdated, inaccurate maps anymore. You can call for a rescue, use satellite navigation, and so on. Sure, we're long past the era of wooden sailing ships. Today, you've got advanced vessels built from steel, composites, and other durable materials, but you don't seriously think that makes the Drake Passage totally safe, do you? For example, in March 2001, the small expedition ship National Geographic Endeavour was knocked off course by a massive wave about 98 feet high. The bridge windows were smashed, and the crew lost navigation and communications. Still, the ship managed to reach port a few days later with the help of a tug. And here's a much more recent case. In 2025, 39-foot waves slammed into a Quark Expeditions cruise ship, and several passengers were injured due to the violent rolling. In short, the Drake Passage remains extremely dangerous. So that raises the question, why do tens of thousands of ships pass through this perilous stretch every year? Adventure seekers are easy to explain. They're literally chasing the thrill. Cruise ships are easy too. Tourists often want to visit places that aren't exactly ordinary. Cargo ships also pass through the Drake Passage, and for them, the priority is simple: get from point A to point B without drama. And at the same time, these ships have a much safer alternative to move between the Atlantic and the Pacific, or vice versa: the Panama Canal. What are they doing in the Drake Passage? The catch is that the Panama Canal is safer, but it's not perfect. Not every ship can fit. The locks are about 1,201 feet long and 161 feet wide, with a maximum allowed draft of roughly 49 feet. For supertankers and the very largest container ships, that's just not enough. They physically can't squeeze through. And even if a ship does fit, that doesn't mean it can sail straight in. The canal runs on a tight schedule. You wait your turn, enter the locks down to the minute, and depend on the entire system running smoothly. Any hiccup and the vessel is stuck. At this scale, stuck doesn't mean hours, it can mean days, and hundreds of thousands of dollars lost to downtime. Sure, plenty of very large ships still use Panama, sometimes with reduced load. So why hasn't traffic through the Drake Passage disappeared? Because Panama has other major drawbacks. The Panama Canal depends directly on fresh water. Its locks are filled from reservoirs, and in recent years, that water's been running short more and more often, especially during the dry season. When that happens, the canal has to cut capacity, impose restrictions, or delay ships for a day or longer, simply because water levels aren't high enough for safe passage. Here's a clear example. In 2023, during Panama's most severe drought in decades, authorities reduced daily transits from the usual 38 to 40 ships to roughly 22 to 24. And the worst part is, it didn't end there. Restrictions stayed in place throughout 2023 and into part of 2024. What does that mean for shipping companies? It's basically a nightmare scenario. Schedules collapse, supply chains snap, losses pile up, and suddenly even the most dangerous route starts to look like a workable alternative. That's when the Drake Passage comes back into the conversation. Brutal, risky, but predictable in one way. Once you're out in the open ocean, you keep moving. No waiting, no stops. So what's the bottom line? When the Panama Canal has problems, do container ships really have only one way to get from the Atlantic to the Pacific? Through the deadly Drake Passage? Not quite. There's another option, and it's far more dangerous. Deadly route. First, a quick historical note. In 1845, British Admiral Sir John Franklin set out on an expedition aboard the Erebus and Terror. In the end, every member of the crew, 129 men, perished. It remains one of the greatest tragedies in the history of seafaring. What's most astonishing is that the ships were found only about 170 years later. Then in 1850, the ship Investigator went to the same region to search for Franklin's expedition and ended up trapped as well. It too was discovered many years later. So where is this marine black hole? All these events took place in Canada's Northwest Passage, long seen as a potential route between the Atlantic and the Pacific. But as you can tell, it's incredibly dangerous. What's really going on up there? The first and most obvious obstacle is the ice. In the straits and around the islands, it can be wildly unpredictable. Even in summer, when parts of the Arctic finally loosen their grip, huge slabs of ice keep drifting through, forming impassable choke points where ships can end up trapped for weeks. Honestly, that alone would be reason enough to choose a different route. But that's not the whole story. Let's look at the map. The Northwest Passage is a maze of narrow, twisting channels. If the Drake Passage and the Panama Canal are more or less a straight shot, this one requires constant maneuvering, and with near-perfect precision. One wrong move and the ship runs aground or cracks its hull. In a place this cold and empty, that's almost a guaranteed disaster. So why weren't stranded ships rescued here in the past? Simple. There's nothing to support it. No emergency ports, no refueling stations, no repair services, and there are no rescue vessels anywhere within hundreds of miles. In other words, any accident turns into a long, brutal fight to survive. And finally, the Northwest Passage is brutal weather in its purest form. Gale force winds, blizzards, fog, and sudden temperature swings. Even seasoned crews can get trapped, and forecasts up here are almost useless. And if the route is that dangerous, why is it still being pitched as an alternative to the Panama Canal? You'd think this is where technology saves the day. Satellites can track ships with feet-level accuracy, weather updates arrive almost in real time, and modern ice-capable vessels can operate in places where ships used to turn back. In theory, all of that should make navigating the icy maze noticeably safer. The danger doesn't disappear, but it feels more managed, fewer surprises, more calculation. Does it actually work that way? Not really. In 2023, 42 ships transited the Northwest Passage. In 2024, only 18 did. That's nowhere near the volumes of the main alternatives, because the truth is the passage remains hazardous no matter how well you prepare. Here's a telling example. In 2010, the cruise ship Clipper Adventure took tourists through the Northwest Passage. The vessel was outfitted for Arctic conditions with a reinforced hull and an experienced crew, but it wasn't enough. In the Simpson Strait, the ship struck a submerged shoal and came to a stop. After that, there was only waiting and the evacuation of passengers. 8 years later, history repeated itself. In 2018, the research vessel Academic Iaffe, with 163 people aboard, ran aground in one of the Arctic straits. Things escalated fast. Passengers were transferred to another ship, fuel leaked into the sea, and the expedition was essentially derailed. And this wasn't a tourist cruise liner. It was a scientific vessel with a trained crew and specialized equipment. That's why it feels paradoxical. On paper, there's an alternative, but in practice, it's like there isn't. And if we pretend the Northwest Passage doesn't exist and keep sending ships through the Panama Canal or the stormy Drake Passage, that's not a real option, because the northern route is already starting to change. Here's what's happening. In summer, Arctic sea ice keeps retreating. And this isn't a one-off anomaly, but a sustained trend. The period when large areas of the Arctic are free of continuous ice is getting longer, year after year, season after season. So how does that help the Northwest Passage? According to climate models, by the middle of the 21st century, this route could be navigable for most of the summer. Some straits will start clearing of ice even earlier. The ice is thinning and becoming looser. Large floes are less and less likely to be pressed against the coast, and the classic Arctic traps where ships used to get stuck for weeks are gradually becoming less dangerous. And if that sounds like science fiction, it's not. The potential is real. At least one of the ocean's most hazardous routes may have a brighter future ahead.